Hi, welcome again to our review this morning, this day. And as part of our knowledge on how we can name compounds, let me begin with our objectives. And those are first, we need to identify the ways on how to name a binary compound and a ternary ionic compound. And the second one, after you do know or identify the ways on how to name the binary and the ternary, you are going to name it this binary ionic compound and ternary ionic compound by your own as part of the practice. And of course, your ability to name those compounds and write those formulas will hinge on your ability to recognize whether this a compound or whether this compound is ionic or a molecular one. So, what are you waiting for? Let's start with the first, and that is naming binary ionic compounds. So, these are the rules that you need to remember. Number one, binary means that it composed of two elements. Ionic means that it composed of metal and a non-metal, or a cation and an anion. So first, binary means two elements, meaning it's a combination or chemical compound in between metal, which is a cation, and a non-metal, which is an anion. So remember that when it comes to writing a formulas, charges must be balanced so that the compound will, or the charges of the compound will become neutral. So as a part of review also, remember, cation, it is the one that lose two or more electrons. And an anion means that it receives or it's the one that gains two or more electrons. And now, in writing these formulas, the first word is a cation, the second one is an anion, and the name of the second word ends up with IDE. Some cases for the binary ionic compounds. So since the cation loses two or more electrons, it becomes positively charged due to the numbers of or an equal number of electrons and protons. So a neutral atom do usually have the same number of protons and electrons. But in this case, during the ionic bonding, it means that if it loses one electron or two electrons, then therefore the number of protons will become bigger than the number of electrons now in that particular element. So that is a cation. And in terms of anion, it turns out to be a negatively charged atom because it gains one or two or more electrons coming from the cation. And since it's not a neutral atom anymore, rather the number of electrons become bigger than the number of protons. So there will be an equal number of protons and electrons here. An example is a sodium bromide or NaBr. So why is it NaBr? Remember first that sodium is a metal, it is a cation, and bromine is an anion or a nonmetal. Another example is the magnesium fluoride. Magnesium is a metal which is a cation, and fluoride is a nonmetal which is an anion. So in naming binary ionic compound, remember the rules. Number one, you have to use the same first element name. Do not change it. If that is magnesium, if that is aluminum, whatever metal it is, do not change the first or the name of the first element. And then on the second element, which is the anion, you have to change it. In binary, remember it is in binary ionic compound. You have to change the last or the ending sound into by adding IDE. So if that is bromine, it will turn into bromide. If that is a sulfur, then it will turn into a sulfide. So let us have here examples like the sodium fluoride, sodium and fluorine. So sodium remains the same, that is the cation, a metal, and fluorine ends up with IDE. From fluorine, it turns into fluoride. Same thing happens with potassium, sulfur. Potassium and sulfur turns into potassium sulfide. And last, magnesium and nitrogen. That turns out to be magnesium nitride. I have another here, lithium and oxygen. You may call it lithium oxide. So I hope you can now recognize a binary ionic compound. They usually ends with IDE. So let's try to do LiCl, CAS, and MgBr2. Let me see. In number one, LiCl, this is named lithium chloride. Number two is calcium sulfide. And number three, magnesium bromide. In naming transition metals compound, the Roman numeral will tell you the charge of the transition metal, except for the silver, because its charge is automatically +1. So with the use of Roman numeral, you'll know that the cation's charge is already fixed. So these are transition metals from scandium down to copernicium. They are transition metals. So they are using somehow Roman numeral for you to identify what is the ionic charge of the element. Like in chromium, if that is Roman numeral 2, then automatically the charge of chromium is +2. Or if that is Roman numeral 3, then the ionic charge of chromium is 3. Then you may combine it now, chemically combine it with an anion. Example, an iron oxide. So you'll see that Roman numeral 2 is already been written or already written here. All you have to do is to write it down as its charge. And then oxygen is -2. Since you see they are balanced, 2 and 2, you cancel them out. Since they are balanced, just write down this chemical formula of iron oxide. Same thing happens with iron 3 oxide. Since the Roman numeral is already 3, so if you're going to use they are not balanced using a crisscross method, then you see how it changes its charges to make it balance. So for the iron 2 chloride, the charge of iron is +2 because of the Roman numeral 2, and then chlorine is -1. They are not balanced. So do the crisscross method by writing down like, and after doing so, write down their chemical formula. So let's do it here. With copper phosphate, copper 2 phosphide, and iron 3 nitrate. So what will happen? For the copper 1 phosphate, this is the chemical formula, Cu3PO4 phosphate. Remember, when you see ATE automatically combined, they are polyatomic ionic bond. So they are fixed in value. PO4 for the phosphate. Phosphide, then iron 3 nitrate. This is fixed in O3. They are called polyatomic ionic compound because they are tightly bound groups of atoms that behave as a unit and they carry charges. These are the usual na ginagamit that we used in chemistry. The sulfate, the nitrate, and the chlorate. And there are some other examples here if you want to take note of the value of their charge. In ternary ionic compound, there are three different elements combined together. Usually, they contain polyatomic ions. Remember, ionic means there is a cation and anion. And these are the examples. For the calcium nitrate, since the charges are not balanced, do the crisscross method. Since nitrate is already a unit of polyatomic ionic compound, we have to use an open close parenthesis. But still, you have to do the crisscross method if they are not balanced. But do not change the value of nitrate or the chemical formula of nitrate. Same goes with aluminum hydroxide. Since there is a polyatomic ionic compound here, it uses, of course, an open close parenthesis. Same goes with a barium sulfate, sodium phosphate. Remember that you have to reduce the subscript since they are balanced, no need for you to write it down. And if ever there is no subscript anymore, then do not use open close parenthesis for the sulfate here. No need for that if they are already balanced. And for the sodium phosphate, Na3PO4, remember you can only use parenthesis with polyatomic ions like this, the first three examples here. And for the potassium sulfate, P2SO4, we cannot reduce it anymore to polyatomic formula. So let's do it here in my examples. Number 1, what would that be? Number 2, number 3. So let us see. For number 1, it's barium phosphate. For number 2, it's aluminum sulfate. And for the number 3, it is strontium phosphate. So I hope you learned something from our topic this time. See you soon for the next entertaining chemistry, naming chemical compounds. See you again. Bye-bye.